Hello, welcome to the seventh part of the C++ guide for JavaScript developers. I'm Oscar, and today we're gonna be looking into lambda expressions. Now, unlike previous chapters, I would actually recommend for you to even quickly go through the documentation. I know there's a lot in here, but lambdas are quite complex on their own. There's a lot of semantics. But we will go over a simple example, and hopefully this will help you understand better what's going on. So we're gonna start with creating a factory function for lambdas, just because I want you to see the return type of lambdas, not just use them in the main function, but actually creating a function that creates more functions. So in order to do this, I have already included the functional library. This is part of the standard library, and I'm using the std namespace. So I'm gonna declare here a function. I'm gonna call it the sum4, and I'm gonna create a new function. I create some n function that takes one argument. So the idea is that if I want to have a sum5 function, I would instead call this as sum5, right? So we now have to create some n function, which is the generic factory that will create more lambda functions for me. In order to do this, I first declare the return type. So the return type of this function is another function. And the function type is a little bit different because we need to first declare the return type of the returned function plus the types of all the arguments that we're going to use inside of that lambda function. So if I would have more ints and a string, for example, this means the lambda function that's returned takes 2 ints and a string, and finally returns an int. In our case, we only need 1 int, so we can leave it like that. Then comes the name of my factory function, and finally the bounded value that I'm going to use. So now we can actually create our lambda function. I'm going to return first. I'm going to use the square brackets. This is the capture values. So if you haven't seen the previous video, I would recommend for you to go back to it and take a look, because this deals with the scope of functions. So as we mentioned before, a function declared inside of a function inherits the scope. But unlike on JavaScript, where the scopes are kept alive for me, that's what the JavaScript virtual machine does. On C++, I need to be more explicit about what needs to survive and what can be deallocated or not. So in this case, I'm going to go for a very useful shortcut. We will come back and revisit it later. But for now, I'm just going to use the equal sign. Equal meaning that whatever is the scope of the calling function, I'm gonna capture all of it, right? So the compiler is gonna keep all the variables inside of the parent function alive for me. It's not going to deallocate them, so I can safely use them. Next come the parentheses, and here's where I declare the arguments for my lambda function. I'm going to call the first parameter an integer. And finally, I can implement the body of my function. So inside of this body, I'm just going to say I'm going to return x plus n. And that's it. Now I have a function that creates more functions. Inside of my main function, I can call this with integer argument. If I execute this function, then I should see the result. I could declare one more extra function. So instead of doing sum of 4, I'll do sum of 5. and so on and so forth. So here you see this is a factory. It's effectively creating more functions. Now let's revisit the capture semantics a little bit more. Like I said, the equal shortcut is very useful, but it could be inside of this function I have created a very large array, for example, right? Or I created a bunch of objects that I don't need. Then capturing the entire scope might not be what you want, because for every single time you create a function, you're gonna waste a lot of memory. So you can actually specify single values in here. Let's say, in this case, I only want to capture the end parameter, because that's what's important to me. If I need to capture more stuff, then, you know, I just put a comma between the values. But for now, just capturing the end value should be enough. And we can see that it correctly captures the value. If I wouldn't have this, then the compiler is going to complain immediately, right? It cannot be implicitly captured. This is part of the safety flags of the compiler. You can of course disable it, but again, you have to take into account once this function finishes running, it will return the lambda, then its context, and by its context I mean also its arguments, they're gonna get deallocated. So here, instead of having this 4 value, you know, I'm gonna end up with some random number that's gonna be on that memory address. The other important aspect that we need to take care of is pointers. At some point, you will stop passing single values, simple values, right? Like ints and booleans and so on. You might start receiving, if you have a struct, you know, you might receive your own struct in here. And then the capture semantics get a little bit more complex. Or for example, I could get a pointer to a string, right? So here I need to make sure that I'm actually capturing what I am trying to reference, right? Or is it like this? If I don't dereference or, you know, capture the pointer itself, then I'm going to be reading the memory address, and this is once again going to be wrong. So you just need to be careful. You need to be conscious about what you're capturing. Now, you could also specify a return type for your function. This is not declared on the factory function itself, but on the lambda function, right? So now you can see the return types don't match, because this is returning an integer, and this lambda is saying, well, I'm returning void, right? I'm doing a void operation, so I don't need to return anything. So first, of course, we need to modify the return of our function, and we're gonna return void. This is how you return void inside of the lambdas. But we also need to return, or we need to modify our factory function, right? In order to match the expected return with our actual lambda implementation. So what's going to happen now is that because it returns void, you cannot output it into the console. I am just going to have to call this. And inside of here, now my lambda function, right now it's not doing anything, but I actually wanted to output the result of the computation. So I'm just going to move it inside of the lambda, and we can see they are correct. Now, lambdas are very useful, or actually they're required for use the React Native JSI. If you are just learning C++, you might be able to never use them, but that's why I decided to cover them. On the next video, I would like to talk a little bit more about memory and pointers. We have so far done a very, very high level introduction, but I would actually like to explore a little bit more examples. And then finally, we're going to start talking about the JSI. If you're not a React Native developer, you probably don't need about you don't need to know about the JSI knowledge, but there's still a lot of very interesting concepts in there. Thank you for watching. Please consider subscribing, and see you next time.